What's going on, guys? Welcome back to the shop. So this video is going to focus on a problem that I have, and that problem is, well, we're running out of dry wood. So when we were doing the shop build, I did a short little introduction of a stand-up freezer that we were going to be down the road turning into a kiln. Well, the time has come. So where we move now, I have miles upon miles of mountains to explore. I happen to be a semi-professional burl hunter. And yeah, I spent some time out in the wild foraging for some interesting pieces, and well, we need to be able to process them under 3 years because the air drying is just not going to do it. So that brings us to this glorious piece of machinery here. This is your luxury model Kenmore stand-up insulated box, because that's all we really need it for, complete with door dent, crusty dried up beer, a little bit of seal mold, and don't forget the rust. All right, yeah, so in all of her glory, there will be our new kiln. Now, I know there are other videos out there on YouTube. I know Sprague Wood Turning has a great series that he put together for the style of kiln that he put together. And I know Carl Jacobson has a video out there also. But this particular unit, or at least the plan for this particular unit, is going to be something much different. I intend with this here project to marry these two together. This here is a dehumidifier. Looks to be, I don't know, probably early 80s, which means it works well. So yeah, we're going to be putting together a dehumidification kiln that's going to allow us to run lower temperatures and still achieve some fast dry times. So just getting started here, I'm going to get this guy cleaned up, and then we'll focus a little more on the specifics. Let's get to work. All right, it's like brandy new-ish. All right, so in the beginning of this here presentation, I referred to this here stand-up freezer as an insulated box because, well, it's pretty much all it is to us. But there are some key design features in here that we will also be utilizing. For instance, we have our fan mounted here, and this is basically a false wall. So the fan is going to be pulling air and putting it behind this wall here and flow it up and out the top. We'll be utilizing this here baffle. It's an internal baffle. So we will get airflow from the bottom to the top and circulate that way. So that is one of the key elements of a kiln, is you need air circulation. Now we're going to be taking a look at how this guy was set up originally. Is the cooling coil was mounted down here. We're basically going to be doing the same thing. It's just not going to be as powerful as a system for cooling. So if you think about any refrigerator, freezer, dehumidifier, heat pump, any of those things, they're all effectively the same type of system. It's just how you use it. And in this case, we're going to be using a refrigeration system to condensate moisture out of the air. So moving forward here, I'm going to move on over to our dehumidifier here, get it deconstructed and start figuring out what we got to do to marry the two. So let's get on with that. Get this guy stripped down, take a look at its raw components, figure out how we can utilize that inside of our here insulated box. All right, guys, let's get this crusty old girl broken down and start working towards giving her a new outlook on life. New purpose. Oh man, look at, oh, we got squares. Isn't that convenient? It's alive! It's alive! Now I want to see how effective this coil still is without cooling on the hot side. How much heat is actually produced. I gotta figure out whether or not we need to put a fan on this. Alright guys, so I got this down here on the floor. I got these lines bent up a little bit better to fit our configuration here. So looking at how she's sitting in comparison to the compartment that we have here. So obviously the compressor is going to mount in this spot, and then we have our cooling coil, and that's going to be up inside, and then this coil will be mounted flat like this further on down in there. Now Get you down in there, take a look. Should do the trick. It's just holding it up so it's not dangling there. So yeah, we got everything routed and mounted. I don't think I pinched or broke any of the lines. So we're gonna go back inside this guy, mount our internal coil, and we'll pick up there. Today is tomorrow all over again. Let's get back in this freezer, kiln, whatever you want to call it. Our foam cured up overnight. So I'm gonna get that trimmed up and we'll get our little drip catch panel back in there. You can see it's tapered down towards the drain. So yeah, let's do that. I'm gonna get that trimmed up. We'll get this this panel laid back in, and then we'll start taking care of the rust. All right, so taking a look on into our cabinet here, we got a nice coat of bright white gloss paint on here. She's looking brandy new and fresh. So while we're waiting for all that to dry, I got to start thinking about some wiring here. Now we're doing our best to utilize everything that's been given to us. So the existing wire harness runs through this little insulated compartment, and that wiring continues down to underneath in the little equipment compartment there. So the wiring's pretty much already run for our fan, but the only thing that's gonna make this a kiln is a heater. So we gotta get a circuit run inside here to power up our heater. Wow. That's that good Amazon stuff. I think we're gonna have to try and find another hole saw. Oh man. Alright guys, so I went to do a little bit of testing after getting this guy wired up, and in typical Duca Heritage fashion, Murphy's Law prevails, and our fan that we got in here, no good, no bueno. I went to power it up, and first it was locked up. So then I took it apart, cleaned it up, cleaned the commutator. Still no bueno. So, ran down to the local hardware store, picked us up one of these here blower kits. I don't know if you can see in there, but yeah, pretty similar motor design, and it should work. Alright guys, well, we got a functional fan now. We rewired it to accept the same harness connection. Had to modify the bracket a bit. The orientation of the hardware on this motor was linear while the other was offset, and we had to go and reconfigure the motor itself to get us the appropriate directional rotation. But after all that, we do happen to have a functional fan. So that's a plus. Now, on to the next order of business. After taking a look at the wire that was run here for whatever, I don't know what these things were for, temperature sensor, I don't know. Whatever they were for. I don't know if you can see this, but this is like tiny wire gauge. I don't know, like 24 gauge or something stupid like that. And that's definitely not going to support our heater. So what I'm gonna do is we're gonna scrounged up. I was able to scrounge up a receptacle and a box. So I'm thinking just run our own wire. Probably go straight through the bottom, get this guy mounted in here to the side, then that way if during testing we have to make changes, add different heaters, multiple heaters, who knows, at least we'll have that available. So that's what I'm gonna do now. Around ours. Well, that's no good. I swear, you can't make up some of the stuff that happens around here. I never would have guessed that this harness bundle turned the corner before it went down, but yeah, found out the hard way on that one. So my workaround was we're using this receptacle box also as a junction box for our fan, so that just runs through and out. And then this is going to be on its own independent circuit specifically for the heater, while the fan will be powered full time to maintain air circulation. All right, so that brings us to the next part here, our control system. So this is an Inkbird set of temperature and humidity controllers. This guy runs heating and cooling. This will run humidifier, dehumidifier, whatever you need it to do basically. So we have our probe leads. This guy is humidity, this guy being temperature. This is a set I had from another project. But I think you can pick up this set on Amazon for like 75 bucks. And well, they work well, they come in handy. This is just gonna be for power distribution. So this will be plugged into the wall, and that'll be how we're getting our power to the different pieces of equipment attached to this. So I'm gonna get everything connected, cleaned up, and then we can finally get into some testing. All right, guys, well, that's pretty much all the wiring. This guy's gonna come in off the wall. We got power provided to each of our controllers. Got constant power going to our fan. And this here is going down to the dehumidification coil. And this guy's gonna run our heater. So, yeah, let me just grab the heater that we're gonna be using. We'll begin some testing. Yeah, all right, guys. Well, today is tomorrow, and we've gone through our first round of testing here. Now, in doing so, we have identified at least one particular problem. Everything seems to function properly, except for our compressor is going into a thermal overload shutdown kind of thing. So basically we're not removing enough heat from the system, and it's shutting the compressor down. So I'm gonna get this guy tipped over. We're gonna take a look. I have a feeling by the way that we mounted the condenser coil down there that we just have too much heat density building up, and we're not cooling the refrigerant off enough before it gets into the compressor. So we're gonna get to the underside of this guy, see how we can get maybe a fan mounted in there, or just figure out how we can get some of that heat out of there. Let's do it. So I think the first thing I'm gonna do is we're gonna get some lumber underneath the bottom here, get us a little extra lift, and that will help allow us to circulate more air under and through. So I'm just gonna get a quick measurement. We'll get us some risers built here. Alright, getting on in here and taking a closer look. So we got our fan mounted. We are fastened to the back wall as well as this cross piece. We will be blowing straight through the condenser coil. And we should have enough space to evacuate that through here. I'm liking it. All right, let's get this guy stood back up and we will commence with some testing. All right, guys, well, we got this all put together. It's windy outside. All right, guys, well, we got this all put together, so let's talk about what it is that we're actually trying to do. So in any drying operation, what you're trying to do is get your finished piece within 2% of its in-use moisture content, okay? So as a standard rule of thumb, typically as far as like furniture, cabinetry, or anything that's going to reside indoors, you're trying to target somewhere around like a 6 to 8% moisture content of the actual piece, which is going to be equivalent to about 30 to 45% relative humidity. And that's just a general rule of thumb for interior spaces in North American climate and region. Now, obviously, you get a little closer to the equator, you're probably going to be dealing with a little more humidity. So your target, your end goal for the piece that you're working on is going to be slightly higher. So with that in mind, I loaded up our kiln here with some random stuff I had laying around the shop, just some random pieces, and none of this stuff is green. Most of it has been air drying for quite a while. So let me show you what we came up with for our first 24-hour drying cycle. So there you go. On our first 24 hours, we were able to accumulate about 16 ounces of water. And these are the settings I ended up with after toying around with the actual operation of this. We're sitting at 90 degrees Fahrenheit and 30% relative humidity. With these settings, I was able to get some really good cycling on our refrigerant compressor. I don't want to overrun the compressor because you stand more of a chance of building a block of ice on the coil rather than having the moisture run out into our collection. So yeah, I'm feeling really good about these current settings, but that is only with what's currently inside there. Now, one thing I did notice is that I can tell it's drying out because the off time between cycles is increasing, meaning the heat and the compressor are cycling less as we get closer to our dry point. So it's going to take a lot of you know, tweaking around with. I'm sure totally green wood is going to be much different. But in the future, if you guys are interested in following along with the work I do with this as far as data collection and basically just the results that we get with different, you know, different situations, different types of wood and different moisture content to start with, I would be happy to put together some video content. Just let me know in the comments if that's something you guys would like to see. And I'll keep it coming for you instead of just keeping it to myself. But yeah, there you have it. This is going to be an ongoing project, and I look forward to learning the ins and outs of this. And you know, everybody wants to dry their work as fast as possible in as low stress of a situation as possible. So that was ultimately the idea behind this here project. So I'm feeling good about it. I hope you guys are too. So yeah, if you like this stuff and you want to support the channel, give us a thumbs up. If you haven't yet, consider subscribing. We do weekly content. I have a couple of other shop tool builds in mind, but mostly we're just doing turning and you know, whatever comes to mind. So yeah, I look forward to hearing your guys' thoughts. Let me know what you think. And other than that, I love you guys. I'll see you next week.